Hello, friends. This is Mr. Bear, and I'm here to talk about skill 46, which is solving a logarithmic equation. So, I'm going to start with some steps, and once I go through those steps, and notice that I have an example on the side that will allow us to see these steps in action. After we go through some steps, we're going to go through some example problems as you see here and here. And once we're done with this video, you should be ready to begin on your IP. All right, so today we're going to solve logarithmic equations. So the first thing that I want to do is just quickly take a moment to review our log properties. Our first property being what I call the product property. Okay, the product property says that if you have, and I'm going to use generic log terms, so keep in mind that the logs could be of a certain base. Let's say I have a log of, let's do the expanded form and show how it condenses. So let's say I have log x plus log y. The product property says that if you are adding two separate logs, you could condense the logs together by writing it as the log of the arguments multiplied. Okay? It's kind of like thinking about when you added your exponents in exponentials, that was when you had a product. Think of this logarithmic as kind of being the opposite of that. So you're adding two logs, you can condense them by multiplying those arguments, which are like which is like what you do with exponentials. Remember, a to the x times a to the y was equal to a to the x plus y. So just another way to kind of help you think about that. Second one I want to talk about is the quotient property. Quotient property says if I have log x minus log y, I can rewrite that as log of the quotient x over y. And you may remember that we did this when we had a to the x over a to the y. We wrote that as a to the power of x minus y. So it's just showing that when you were subtracting exponents, it was from a quotient. And so same idea happens with logs. So let's look at an example. Suppose you have an equation, a logarithmic equation, that has only one logarithm expression. Well, if that is the case, then the very first thing you're going to do is isolate the log. And that would be by using one of these product or quotient properties. So you might have to do some condensing. Okay. Step 2 is going to then be to rewrite as exponential. Okay. And solve. So you can do that. And then step 3, and we're always going to do this, is check for solutions, or I should call it extraneous solutions, okay? And we'll always do that no matter which type we solve, because we're going to talk about in a moment what happens if you have a solution that causes a log to be negative. All right, so in my example, I don't only have one logarithm expression. I have a logarithm on both sides, so I'm not going to follow these steps, or at least not all of them. But if a logarithm has logs on both sides of the equation, first thing you do is you still condense anything that you can. So condense any logs that are needed. And again, that's using these properties up here. Step 2 is going to be to exponentiate both sides. And you're going to do that by using whatever your log's base is. Okay. And that's actually how we're going to handle this first problem here. So I'm going to go ahead and try this out, okay? So on the left side, I notice that I have natural log rather, of x plus 2 plus natural log of x, okay? So I have a plus sign here, so going back to my two properties here, when I have a plus in the middle, that means I'm using the product property. So I'm going to multiply my arguments. So I'm going to condense this to the natural log rather, of x plus 2 times x, okay? Which thus gives us, if I distribute this out, I get x squared plus 2x. Okay. So that takes care of step 1. Step 2 says rewrite it. Oh, wait, I'm looking at the wrong set of steps. We're not doing that first part. We're doing the second part. So first part is done. We've condensed any logs necessary. So second step is going to be to exponentiate both sides of this equation by using the base of the given log. Well, remember natural log is the inverse of e. So I'm going to e both sides here. And so what that means is e cancels with natural log, so I just have x squared plus 2x. And on the right side, e cancels with natural log, so I just have 8. Okay, now this should be looking familiar to you. This is a quadratic, so when we have a quadratic equation, we got to set one side equal to 0. Easiest way to do that is subtract 8 from both sides. Okay, so let's not forget those skills we haven't done in a while. All right, so to solve something like this, we're going to factor, or you could use quadratic formula. I think I could find two numbers that multiply to -8 and add to 2. That would be, let's see, 6 and -4. No, that would not be true. How about 4 and -2? Sorry. 4 and -2. All right. So this is a shortcut factoring. I could write this as x plus 4 and x minus 2. So that gives me solutions of x equals -4 and x equals 2. And in a moment, we're going to check those. Okay? So what we always want to do is we always want to check. So in the end, we always check to make sure logs are not negative. Okay, so what that means is not our x values being negative, but the actual value of the logarithms are not negative. So what I'm going to do is go back to my original equation. Okay, in my original equation, I'm going to pick a different color here. Let's use pink. I want to check to make sure that x plus 2 and x, I want to make sure that those don't become negative numbers when I plug in these solutions. Well, if I plug in x equals -4, I can see that this log right here, this value, becomes a negative number. So that is out. If I plug in positive 2, 2 plus 2 makes 4, so that's good. 2 is already positive. So x equals 2 is our valid solution, okay? So that x equals -4, that's that concept of an extraneous solution, okay? So just like at school, you only want positive logs. That's how it's going to be here in our logarithm equations. By the way, if none of those steps that we did will actually work to be able to solve a log, then what you do is you graph and look for the intersection. Okay, that's kind of like what we did with the exponentials. We got out Desmos and we looked at where those two sides of the equation crossed each other, and wherever they crossed at, that was the x value rather, was our solution. All right? So let's go ahead and see how to do some problems here. On the first one, first I am required to condense these logs, so I'm going to use, I got a minus sign here, so I'm using the quotient property. So I'm going to write this log base 2. Since I'm using the quotient property, I'm going to have x plus 2 over x minus 1 equals 3. All right, so I do not have a log on both sides, so according to my steps, I have to rewrite as an exponential. So my base is 2, so this will be 2 to the third equals x plus 2 over x minus 1. So that'll be the same as 8 over 1 equals x plus 2 over x minus 1. We're going to cross multiply here, so we get 8 times x minus 1 equals 1 times x plus 2. I don't really need to put the 1. 8x minus 8 equals x plus 2. Let's see, I'd be subtracting x from both sides, and then I'd be adding 8 to both sides. So x would have to be 10/7. When I plug in 10/7 to this x, I get a positive value in the end, so that's good. And when I plug in 10/7 here, 10/7 is a little more than 1, so when I subtract 1 from it, I'm good. So no negative logs here, there's my answer. Next one, I could see that the two sides are both written with logs. However, I don't have to do any condensing. So I'm going to go right to step 2, which is exponentiate both sides. Remember, natural log is the inverse of e, so I'm going to e both sides. That's how I'm going to exponentiate. So that e cancels with natural log, giving me x plus 3. And e cancels with natural log to give me 2. I'm going to take away 3 from both sides, and I get x equals -1. Now, please don't sit here and say, oh, we got a negative answer, so this must mean it doesn't work. No, it's not if the answer of x is negative. Please know that. It is if when you plug in the -1 to the log expression, if that is negative, that's a no-no. Well, -1 plus 3 is +2, so we're good. So x equals -1 is a solution. So please, I repeat, do not say that something that is a negative answer, like so, automatically means there is no solution. Okay? I saw a lot of this mistake in Algebra 2. Please don't make that mistake now that you're older and wiser. All right. Sorry if I sound like I was yelling at you. Just don't like mistakes. And I know I make plenty of them, so I'm just hoping that you don't. All right, I'm being a dork now. All right, let's go ahead and continue on. On the next one, I need to get this log by itself. However, I don't have to condense any logs because this is just a -3. So we're just going to add 3 to both sides. And that gives me log base 3 of 2x minus 1 equals 4. And since I don't have a log on both sides of the equation, I rewrite this as exponential. So 3 to the 4th equals 2x minus 1. Okay. 3 to the 4th is 81. Whoops, that would have been 82. I'm adding 1. Divide by 2, I'd get 41. Well, 41, when I plug that in here, we're safe. That's going to be a positive value. So far, so good. All right, these next ones, I may not have enough time to go through every last detail of these, but what I'll do is I'll get them started. I'll explain like how to do them, and then you can kind of finish it out. So here I'm going to condense those logs by the product property. So x times x plus 3. So I'm going to multiply x times x plus 3. I have to exponentiate. Remember, this is a common log, so I'm going to do 10 to both sides. And I get x squared plus 3x, that's me distributing, equals 10. X squared plus 3x minus 10 equals 0. I can factor this. Let's see, x plus 5, x minus 2. This gives me x equals -5, and this gives me x equals 2. Plugging in -5, really this one is the easiest one to look at because that right there is just a single variable. That one gives me no go. So x equals 2. Next one, I got to condense here. So I'm going to write this with the quotient. So log base 2 of x minus 3 over x plus 1. This side is just going to be log base 2 of 3/7. So you just set x minus 3 over x plus 1. Oh, I'd be doing 2 to both sides. Equals 3/7. I solve this equation. Let's see, 4x equals, let's see, add 21 to 3, 24, so x equals 6. Checking my logs here, if I plug in 6 for those, that works out, so I'm good. Last one, I'm going to add 3 to both sides. I feel like we just did this problem, did we not? We did, so forget that one. All right, go ahead and try some problems on your own.